Hello everyone, this is Professor Chan from Math 1245. We are going to continue on with section 4.2, dealing with logarithms. Okay, so we're going to talk about the idea of how to graph logs. Okay, now let's talk about the following here. Okay, so let's say you're being asked to graph log base 3 of x. This is going to be significantly difficult to do on your graphing calculator or by hand. Okay, but one thing we need to remember is that logs and exponents are inverses of each other. Now let's talk about how do we solve for inverses. Okay, if you remember all the way back in chapter 2, right, how do we make inverses, right? If I have y is equal to log base 3 of x, right? To find my inverse, I swap them around, right? So I'd say x is equal to log base 3 of y, right? This is how I find inverses, right? I swap them around, okay? So what I want to do is I want to solve for y. So how do I solve for y? I'm going to do log base 3 of y, right? And I do base 3 to cancel it out. Now to balance it out, I have to do base 3 for x as well. So my inverse is actually going to be y is equal to 3 to the x. Okay. So let's talk about this. So my inverse is y is equal to 3 to x. Let's talk about how we graph this, right? So this will be my x and this will be my y, right? So if you remember, so let's see, if I have, let's plug in these points, -1, 0, 1, 2. And maybe I should do this in blue. And let's make my thickness a little bit smaller, okay? So 3 to negative 3 square will be 9. 3 to the first will be 3. And 3 to 0 will be 1. And 3 negative 1 will be 1/3, okay? So this is what my graph of y equals 3 to x looks like, right? So I have 0, 1. I have 1, 3. And I have 2, 9. 1, 1/3. So it looks like this right here. Okay. Okay. So let me zoom out a little bit. Sorry. So we're going to zoom out a little bit right here. Let me go back to 100, okay? So remember, right, so I graph my exponential function, which is pretty straightforward. Remember, if I want to graph log base 3 of x, we know they're inverses of each other. And if you recall, what does it mean if they're inverses? Remember, inverses means your x and y swap around. So my new y becomes my x, and my x becomes my y. Okay? So this will be -1, 0, 1, 2. And then this one will be 1/3, 1, 3, 9. Okay? Let me zoom in. Let's go back to 200 here. Okay? So remember your x and y's, right, will be opposite, and they'll be flipped around from your original, right? So your inverses and your original, your x and y's will be swapped, okay? So let me graph these. Okay, so I have 1, 0, 3, 1, and 9, 2, and 1/3, -1, like this. And it's going to look like the following. Okay, and how do we know they're inverses? obviously because my x and y's are swapped. But another thing too is, remember, it reflects over y equals x, right? Y equals x is my diagonal, right? They're mirror images. This is y is equal to x. Okay, and this is y is equal to log base 3 of x. And this right here is y is equal to 3 to x, okay? Now let's look at the domain of my log base 3 of x. It looks like the following. It's going to be from, if I read from left to right, it's going from 0 to infinity. It doesn't actually touch 0, right? It just kind of touches, it just kind of gets close to it, but doesn't actually touch. My range is actually from negative infinity to infinity, okay? Are all real, okay? Now, it looks like it's increasing very slowly, but remember, as we keep going up, right, as we go further to right, okay, I'm just kind of exaggerating this, but my graph is going to slowly go up, and it's just going to increase without bounds, okay? Now, what is my domain of my inverse? My domain of my inverse, remember, is going to be flipped of my original. So my domain and range of my original, which is log base 3x, will flip when it gets to 3 to, when it goes to y equals 3 to x. So my domain was 0 to infinity. This one will become my range. And then my range of my original will become my domain. And here's the thing, you can see this. Like if you take a look back here, let me just erase this here. Okay, because if you look at this from left to right, you can see that the domain is all real, but then my range, right, only starts from 0 to infinity as well. Okay, so that's something to take in mind. Okay, let's do one more example. For the following here. Okay, so if I want to graph y is equal to log base 1/2 of x, same thing. So if I want to, before I graph, I'm going to find my inverse, and I'll graph my inverse first. So remember, what happens is, if you want to find inverse, remember, if you want to solve an inverse equation, switch your x and y around. So x is equal to log base 1/2 y. We'll solve for y. So I do base 1/2, and then base 1/2 on the other side. So cancel. I have 1/2 raised to the x here. So let's look at the bottom here. Let me do a different color. So I'm going to do x and y. I'm going to do -2, -1, 0, 1. So remember, if you raise this, so if I do 0.5 raised to the -2, this will be 4. 1/2 to the -1 will become 2. Remember, let's just remember this too. If you raise it to -1, it flips. Okay. We're following. 1/2 to 0 is 1, and then 1/2 to the 1 is 1/2, right? So if I graph this here, sorry, let's make this a little bit tinier. It will look like the following. Okay. So sorry, my apologies. It should not be touching. Let me just let me just recorrect that. Okay. So let's look at this. What's my domain? My domain is from negative infinity to infinity, and my range is from 0 to infinity, as you can see right here. Okay. Now, if I want to find my, if I want to graph my log base of 1/2 x, remember your x and y's will be switched around. So let me go back and let's zoom out so I can kind of clearly see here. So I'm going to do this in blue, x and y. So this will become 4, 2, 1, 1/2. This is -2, -1, 0, 1. Let's see how this works. Let me zoom in. So this will be the following. So 4, -2, 2, -1, 1, 0, and then 1, 1/2, 1, which would be like here. So my graph is going to, this blue graph is going to look like this. And as you can see, this is going to, they're reflections of each other here. Now what's my domain? Domain is 0 to infinity. Range is negative infinity to infinity. That makes sense, right? Because my y's and x's will swap around. Okay. We're following. Okay. So do take a look at this, do practice. This does take you a while to get used to, okay? But the easier thing is to graph your exponential first and then swap your coordinates if you're being asked to graph a logarithm, okay? Now, I do want to show you something right here on your graphing calculator, right? So if you notice, your logarithms always will be negative infinity to infinity for your range, okay? The thing you have to be a little bit careful about is, let me show you this to you. So if I graph at my calculator, let's say I'm graphing like log base 10 of x plus 3, right? And I'm graphing it, okay? If you look at this right here, for the following, let's see if I can actually mark this. No, I cannot. Okay, that's okay. So if you look at your graph right here, it looks like your logarithm stops. It actually doesn't. So if you notice, so if you notice your logarithm graph just stops here, you have to realize it actually continuously goes down, okay? So it actually slopes all the way down. It's just that your calculator is not able to show that, okay? So do be mindful of that. Be really careful. So don't say, for example, here your range is from like 2 to infinity. That's not true. It actually technically goes down. So do be very careful about that. Okay, so let's look at one more thing before we end with 4.2. Okay, so it says find a domain of each logarithmic function for the following right here. So remember, if I have numbers inside the parentheses here, okay, remember this means I'm doing a horizontal shift to the left, right? So domains of logarithms without transformations is from negative infinity to, is from 0 to infinity, okay? But if I have x plus 4, right, this is actually going to the left by 4. So my domain this time would be from -4 to infinity. Here inside this is going to the left by 6. So my domain will be from -6 to infinity. Okay. Okay. Same thing with the natural log, right? Same thing here. Inside, right, it's minus, it's opposite, so you're going to the right by 2. So my domain for this one will be 2 to infinity. Now let's take a look at number 3 here. Notice it's 7 minus x, okay? So here's the thing too, you can actually graph this using your graphing calculator. Okay, one thing I do want to let you guys know is when you are graphing log, it only works if you are doing base 10, right? So you can't do things with base 5, base 7, okay? The calculator won't allow you to do that. We'll talk about how to adjust to that later on in the semester. But yeah, but if it's base 10, you're fine, or natural log, you're fine, but you can't do like base 9, log base 9, log base 6, okay? So you can only do log base 10. But let's compare them. So I do log base x, and then let's see if I graph log base 7 minus x, okay? And this is helpful too, right? So you don't necessarily need to memorize it. You just want to have a general good feel. So log of x looks like this. And notice log of 7 minus x is flipped the other way. And notice, so I'm going to remove log of x. So notice it actually goes from left to right, because if you have a negative x here, right, what happens is it actually does a flip. Okay? And then you're adding 7, okay? And you're going to the right. Okay? So this one here, and this can be a little bit confusing, but once again, if you're not sure, you can just graph it. My domain for this one will be from negative infinity, and it stops at 7. Okay? So this one, my domain should be from negative infinity to 3. Let's see if it works. I'm going to graph this. It works, yeah, and it stops right there. Okay. Remember though, your range is still from negative infinity to infinity. Okay. So yeah, and so the idea is, let me just show you one last one. You, once again, like exponential, you'll be asked to graph maybe like, okay, something like this here, and it's actually transformative, okay? So you can still graph log of x, and do the following here. But this transformation, you'd remember where is this going? This is saying you're going to the right by 1, right? Your parent graph is log of x, okay? So log of x, okay, let me show this to you. So if I graph log of x here, I go to my table, I have 1, 0, and I have 10, 1. Okay. But then if I have log of x minus 1, right, that means I'm going to the right by 1. So then my x transforms. So this becomes 2, 0, and 11, 1. Okay. Do the best you can. It's actually going to slope down like this. Okay. Logs also have what's called a horizontal asymptote. So here I have a horizontal asymptote at x equals negative 1, or x equals 1. Okay. And let me just go back and talk about horizontal asymptotes. Remember, that's the line that you can't cross. So let me do this part in red. So here I have a horizontal asymptote at x equals 0. Okay. So I have a horizontal asymptote here. Remember, exponents is the opposite. They'll have a vertical asymptote. Okay. Okay. So that's pretty much it. We're done with 4.2. If you have questions, let me know. But other than that, we'll continue on.